Okay, so you know that this is normally approximately distributed, and they've given you a few things like 16% of the riders were under this certain age, and then 2.5 of the riders were over. So we know, therefore, if we drew our little standard deviation curve, so I'm going to draw it here. So you know you have the mean here. Now, if you have, we're under 16%, how many standard deviations is that away from the mean? -1 if you're under, would you agree? So you know at -1, they said that was 25.5, okay? Now they said 2.5% of the riders were over, so where am I in terms of the mean? Am I +2? Yes, good. Do we all understand that? So up there at +2 is 33 years, okay? So, because what they're saying there, so if I just draw that, because what they told me was that this bit was 16% and this bit was 2.5%, okay? So you know that's what they've given you. Now, they're asking you to find what do you have to find? The mean and the standard deviation. So what you have a look, if you have a look, you know between 33 and 25.5, can you see actually if you counted up the standard deviations, can you see you actually have 1, 2, 3 standard deviations within that age group? Can you understand that? So you see that's essentially 1 standard deviation, that's 2, that's 3. Yeah? So I could say if I found the distance between 33 and 25, so say if I did 33 minus 25.5, yeah, 25.5 would help. 25.5, that equals 7.5. So within 7.5 years, there is 3 standard deviations. So how am I going to find 1 standard deviation? Good, awesome. So if I divide 7.5 by 3, which I get 2.5, that is essentially 1 standard deviation. I now know that 2.5 is 1 standard deviation. So now, how might I find what the mean is? I could use one of the numbers they've given me. Say, if I use 25.5, and if I add a standard deviation, is that going to take me to the mean? Yes? Yep. So therefore, I could say if I did 25.5 and I add 1 standard deviation, that's going to take me to the mean. So the mean that ends up being 28. So we know the mean and we know the standard deviation, which was the answer to the question. Okay, so we're going to look at Z-scores now. So we may call it Z-score, or we might call it standard score, or maybe even if you want just to write under there, they might call it standardized, yeah? Standardized score. Just so like sometimes, different wording throws you. So standardized score. So a standardized score tells you where you are from the mean. So say for example, if I said, and we often call abbreviated Z-score, we call it a Z-score. So if you have a Z-score of 1, what that means is it tells you you're 1 standard deviation from the mean. So if you thought if that's the mean, that means, and you got a standardized score of 1, say so you did your biology exam and they said you got a standard score of 1, that means you are here. So this means Z equals 1 or 1 standard deviation above the mean. So we know you're there and we could say, oh, you're in the top 16%, aren't you? I could say, well, your exam result was in the top 16%. So that's what a Z-score tells you. Now, they're not always going to be perfect. Obviously, when you work out a Z-score, I might have done my biology exam and I might have got a Z-score of minus 2.5. So that means I'm really down the bottom, yeah? I'm not quite at a 3, but I'm worse than a 2, -2. So that's what a Z-score tells you. So how do you calculate a Z-score? That formula is just here. So where you might want to write it out because kids often see this as a little bit confusing. In this formula, X is your actual score. So remember when you're getting a Z-score, it's someone's actual performance or thing that they've done. So X stands for their actual score. Obviously the X with the line means the mean. And they just have written S, but what do we often refer to SX, yeah, as our standard deviation. So you just maybe write that out so you're aware of that's what it's talking about. All right, so as we said in those little dot points, it says the Z-score, if you have a positive Z-score, you're above the mean. Sorry, that's missing the little line. If you're a 0, that means you actually got the average, the mean. You were right in the center. You are 50% are above you, 50% are below you. If you get a negative, you're actually below the mean. All right, so we've got... Okay, so we're going to do these examples now. So it says there's a height of groups of young women have a mean of 160 centimetres and a standard deviation of 8. Determine the Z-score for each of the standard or Z-score for each of these women. All right, so if I write out, I'm just going to write the formula. So the formula is your actual minus the mean over standard deviation. So in this first example, the woman is actually 172. I minus the mean, which is 160, and I divide it by 8. So she ends up with 1.5, a Z-score of 1.5. So if you're 1.5, I might just summarize. I know for sure she's in the top 16% of these women in height. Do you understand? I'm just going to the closest number that we know. So we know 1, 2, and 3 when we talk about percentages. So I at least know she's in the in the top 16. Okay, so let's do the next one. The Z would equal, I'm not going to write the rule because we've got it right there. So 150 minus 160 over 8. So this one's negative 1.25. So because it's negative 1.25, I might say it's definitely -1, not quite -2. So I'm going to say in the bottom 16%. Yeah, so if you had to comment on it, that's what you say. Just go to the nearest one of the 68, 95, 99.7 rule and write it out. Okay, so then the last one, obviously you probably don't really need to even work it out. It's 160 minus 160 over the standard deviation. That person got the mean. So if you get the mean, your Z-score was, we said before, 0. So you get Z is 0. So if you were commenting on this one, you just say, I don't know, if you want to turn it into a positive, you're in the top 50%, or you can say you're in the bottom 50%. You're right on the middle. All right, so what happens is we often use the Z-scores because how I say in terms of the population of that, you can say, all right, you're in the top 16%. Because what happens is say this is an example of someone's year 12 subjects and their study scores, okay, or their test scores or whatever. So when you have a look at it, say often, this is why they standardise when you'll hear about your ATAR and this subject goes up. So we're going to say, all right, chem might be a little bit harder. So at 55, or a 60% on the chem exam, you might be in the top 2.5%, yeah, because it's all, and so this is what they do. They're going to use the Z-scores to compare, to say, what was your best subject? What did you actually go best in? And that's what we're going to do. So if we have a look at this table, we go through. So on the English, the person got a mark of 69 and the mean was 60 and the standard deviation was 4. So if we work out their Z-score using that formula, we get that their 2.25 Z-score. So when it says their performance rating, this is where you just write that little comment. I'm going to say in the top, because it's more than 2, in the top 2.5%. Yeah? And then I do the next one. So this one, biology, they got 75, but the mean was still 60, but standard deviation was 5. So they actually got a 3. So they're very good in biology, and they got in the top, what am I going to say, when you're 3 standard deviations above the mean, what percentage is, what's that little percentage? Yeah, that little percentage, you're in the top 0.15%. Yeah, even better, it's tiny little bit. You're nearly right top of the rank. Okay, with this 55, their mark is 55 and their mean is 55. So do you really need to work it out? What is their Z-score? 0. So we might just say, I'm just going to write 50% above that person. They're right on the 50% mark. So further maths, let's have a look. They got 55, but the mean was 44, but standard deviation was 10, so they ended up with 1.1. So I'm going to say in the top 16%. And then if we look at the psych one, they got 73, but the mean was 82, and we end up with negative 2.25. So they're actually in the bottom 2.5%. So this type of thing could definitely come up on a SAT. Okay, so using standard scores to determine a percentage. Okay, suppose the weight of certain species of bird is normally distributed with a mean of 42 and a standard deviation of 3. If a bird at random from the population has a standard weight of -1, what percentage of the population is the population way more than this bird? So this is exactly what I was saying with the question. You might just want to quickly draw a diagram. If you quickly draw a diagram, you've got your mean 42, and they're saying that the bird is a Z-score of -1. So that means they're sitting down at a -1. Here's the bird. Yeah, because a Z-score tells you how many standard deviations you are away from the mean. So if we're at -1, we know, what's this pocket here? 16%. So they want to know how many, was it more? So how much more would it be to get up to 100? 84, yeah? So 84%, if you do 100 minus the 16, yeah, that will give you things. So the answer for this one, for A, would be the bird 84% way more than the bird. Way more than the bird, yeah. Then the next question was approximately what percentage of the birds lie between 39 and 48? So remember, they're always going to be numbers to do with a standard deviation. So if I minus 1 standard deviation, which was 3, I get to 39. So here's 39. And then they said 48. So if I add 1 standard deviation, I get to 45. If I add 2 standard deviations, I get to 48. So they want to know what's the percentage in here. Oops. In here, this bit in here. So what I might do, just to show you, so what I often just do, this is B. If I was drawing that, I know I'm at -1, which that pocket is 16%, and I know I'm at 2, and that pocket is 2.5%. So in here would be 100 minus those 2 pockets, which would equal 81.5%. Okay? So you can minus the pockets, or what you could have done is, see up here on the diagram, you're here and you're also at here. You could have added those little pockets up, if you like. And that, if you did that, so 34 plus 34 plus 13.5 equals 81.5. So that could be another way. Okay, so sometimes we get given the standard score. So we get given the Z-score, we get given the mean, and we get given the standard deviation. And they say, what did this person actually get? So remember that the actual score is, we referred to the actual score as X, and then we had mean and standard deviation. The standard score we're calling Z, and standard deviation. Okay, so we can use this formula, if you like, to find the actual score. So here, a class test out of 50 has a mean of 34 and standard deviation 4. Joe's Z-score was negative 1.5. Find Joe's actual score. So I've gone to my notes. Actual score equals the mean plus the standard deviation, Z-score plus times standard deviation. So I plug in what I know. I know the mean's the 34. The Z-score was negative 5 for him, times 4. So he got an actual score of 28 out of 50. Okay, so that was his actual score. So you could use, this is a formula that you can use to find the actual score. Or if you want, if you only learn like the Z-score, if you think about here's how we found the Z-score, this is the rule we were using before, you could have put like all the info that you know into that. Yeah, you could have put all the information that you know into that, and you could have used solve if you like. It's up to you, because sometimes just quicker to learn one formula. So if you just know the Z-score formula and you just pop that in. So I understand you always have your reference book, but see how I used that Z-score one and I just did solve. So in the end, I know that Z-score formula, and I could rearrange it to get the actual, but I was like, oh, that'll do. That's the only one I have to, and I can remember that, and I can do it without flicking through my book, which gives me more speed. So, but it's okay if you know, if you have everything handy, that's fine. Just whatever. All right, so let's do this one. I'll just do these two, and then I'll stop. Okay, finding the value of the standard deviation and given the mean and 1%. Okay, so let's have a look. Suppose the heights of red flowering gum trees have a mean of 10.2 and 2.5% grow to more than 11.4 meters tall. Assuming the heights of these trees are normally distributed, what is the standard deviation? So this was like that exam question you just had a go at before. So let's see if we can redo that. So we know the mean is at 10.2. And if I'm 2.5% or more than that, where am I plus or minus standard deviations? Plus, and how many if I get to the 2.5%? 2. So if I go 1, 2 standard deviations above is at 11.4. So, because they told me that this bit was 2.5. So how many standard deviations do we have in here? There's 2, isn't there? There's one there, one there. So if we do 11.4 minus 10.2 and then divide it by 2, because there's 2 of them, that will give me the standard deviation, which ends up being 0.6 equals the standard deviation. Okay? That was because there was 2 standard deviations in between those numbers. Oops, sorry. Okay, the marks scored in an examination are known to be normally distributed. Thank you. 16% of the students scored score more than 80 marks, and 2.5% scored less than 20. Estimate the mean and the standard deviation. So if we quickly draw this diagram up, we would have the mean. Now, if they said 16% score more than 80 marks, so where am I there? What, am I above the mean? Yeah? We're like one standard deviation, would you agree? Yeah? Is this 16%? Yep. And then it says 2.5, and so that we're going to write, they said that was 80. And then they said 2.5 were less than 20 marks. So what am I? Minus 2 standard deviations? Yes? Yeah. So that one would be 2.5%, and they said that was 20. All right, so if we break that up, how many little standard deviations do we have in between those numbers? 3. So if you go 80 minus 20, and I'm going to divide it by the 3 standard deviations, which means it would be 20. Yeah, so we've got the 20 is a standard deviation. And what would the mean be? Yeah, so even if you're at 80, if I minus 20, that would take me to the mean, wouldn't it? Because we're plus 1 standard deviation up. So we're going to say the mean is, I might even just write that, 80 minus 20, there you go, is 60. That's how I found that one. Oops, that's pretty bad, 60. I'll just fix that up.